Okay, so here we'll go. And as you can see, foo temp is going to be originally where foo is pointing, and foo is going to be originally where bar is pointing. And bar isn't going to be pointing anywhere, which is kind of really useless to have bar even sitting around, but bar isn't a waste of memory in any way. So what we can do is we can do bar equals ns string alloc init with string. Now I'll assign it to be howdy. So now we're going to have 3 strings allocated in memory, presumably right next to each other, that we're going to be able to be accessing through foo temp, foo, and bar. So now, here we go. 3 addresses right there. So this is how pointers work. That's why you use a star. All that variable actually is like a 4-digit little number telling the computer where you actually want to go. And that's also what a memory leak is, when you have no variables anymore pointing towards where that variable originally was. So hopefully this was eye-opening to you in some way. If it wasn't, please comment or personal message me and ask me some questions. I'll be open. So now we're going to go over something called malloc. Malloc is a C thing you should have done, but I never got around to it. Malloc basically allocates stuff, so it allocs, but you can malloc a certain amount of space. So I can malloc, say, 20 places in memory, 20 pointers to be this, or 20 bytes to be this one pointer. So you may know about char star. I can assign a char star, and the char star is characters. It's a pointer to a character. So let's say I want to have foo be 10 characters. What you may have done originally is char foo left bracket 512 right bracket. All that really does under the hood is changes this. It adds a star there, and then it calls malloc 512 later on. What I can say is foo equals malloc 10. And what this will do is this literally allocate 10 bytes and assign the address to the first of those 10 bytes to foo. So now foo will be pointing to this place in memory that is going to be used only for foo. That's going to be 10 bytes. So now, if I do print, or no, sorry, nslog p foo, there we go, we're going to see an address. So that's where foo is. It is, in fact, 10 characters. Let's say we malloc it to be 1 character. So now foo is just going to be 1 character. See, the address is exactly the same because that's only the starting address. So here's how it works. Basically, foo is going to, malloc returns a pointer in memory. So a pointer in memory such as 0x, whatever that big number was. So does nsstring alloc. That also returns a pointer. Now, pointers in Objective-C are also represented as IDs. ID just means, under the hood, a pointer. So, like, for instance, now say we do foo equals malloc 1 again. We still have this place in memory that is 1 byte that is mallocked. That means we own this 1 byte. The thing is that now we're making foo point to another byte. We still own this last byte that was 1 byte, but we can no longer have control over this byte. So that's a memory leak. So the way we get rid of this old space in memory before we assign it to a new space in memory, we do free left parenthesis and the name of the pointer right parenthesis. And that will go to where the pointer is pointing, deallocate everything there so you no longer own it. It's just free to anyone who wants to grab that piece of memory. And then assign foo to be 0x0, which means nil, basically. And now I'll malloc foo again, and after I print the pointer, I'm going to do free foo again. So this is now a memory free, or a memory leak free application. So as you can see. So, let's say I don't free foo right here. Before we got this address, the first time right here, on this first malloc, then we freed it so that address no longer pointed to anything. Then we malloced it again. It looked for the first possible address it can get, and it was the same one it got before with this malloc, and then it just used that until another free. If we don't free it, this address right here will continuously be taken up. So how will this show? As you can see, it has to go out and grab a whole new address if we don't call free right here, because this address is still being taken up by this malloc, even when we reassign foo. Which is why on in Objective-C you're going to be seeing a lot of release and dealloc stuff. And that essentially calls free, and alloc essentially calls malloc. So this is how to manage memory. This is a huge major point to know. And if you do not know this after watching this video, which is understandable, I didn't get this for a year, then I beg you to comment on this video and tell me that you don't get what I'm doing. Because I will help you. And I will make sure that you understand, because once you understand this, you'll be a step ahead of everyone who doesn't. Most computer consultants these days who work at big companies, they don't know this stuff. So it's a good idea to be a step ahead. Now, you might not need to know this stuff if you're going to be doing things like Java, but if you're planning on doing Objective-C and you're planning on actually knowing Objective-C, then you better know this stuff, because it's highly important to actually get what you're doing. So this is memory management. Just keep in mind that a char star or an NS string star is really 4 bytes in memory pointing to some other place in memory that is the actual NS string. So this is hard to learn, and I get if you don't get it. So once again, I'm really being repetitive here because I want to make myself clear. Ask me any question, no matter how dumb it seems, because I'll help you. Okay, so anyway, this is Mac Programming Lesson 2. So hope you learned something. If you didn't, I want you to learn something, so ask me. So thanks for watching Mac Heads in 1. Subscribe, and goodbye.